Continuing with section 8.3, we've been looking at how to find all of the details about our graph. Today we're going to start actually putting that into a graph. Okay, so step one is to factor everything. So how would we factor the polynomial y, or the rational function y equals x squared plus x minus 12 divided by x squared minus 4? How does the numerator factor? Okay. Denominator? Okay. All right, so we have everything factored. Second step is to look for all of those details. All right, and it doesn't really matter what order you find them in. Okay, I just started listing all the things that I want you to be able to find. When you take your test, you are going to have to show me work to support this information. We are going to let our calculator help us get our final picture, but all of these details, you have to show me how you're getting them. Okay? So, X-Intercept. We look at what makes the numerator equal to 0. Okay? So, before we can do that, is there anything I can reduce out? Okay, so then I look at any factors in that numerator. What makes it 0? A -4 and a 3. So I have two X-intercepts. So I'm going to have -4, 0, and I'm going to have 3, 0. All right, so put that information on your graph. The two places where we are crossing the x-axis. To find our y-intercept, we plug a 0 in for x. So let's picture plugging a 0 in. You can plug it into the factored form or you can plug it into the original form. All right. In this case, I think plugging it into the original form is easier. If we put zeros in for all of these x's, we are left with a -12 divided by a -4, which gets us a 3. So my y-intercept would be the point 0.03. Okay, go ahead and put that on your graph. Vertical and horizontal asymptotes are the other piece that we want to have listed. So vertical asymptotes, where do we look for those? Yep, those are the domain restrictions, what x can't equal. So we look for the denominator, right? What makes the denominator equal to 0? Positive and -2. And we were not able to get rid of either of those factors, right? So we don't have holes, we actually have vertical asymptotes there. All right, so at x equals 2 and x equals -2, we have two vertical asymptotes. Go ahead and draw those in. And then for horizontal asymptotes, these are the ones where we look at the degree. So we compare the degree of the numerator to the degree of the denominator. What's the degree of the numerator? Okay. Numerator's degree is 2, denominator's degree is 2. So if they are the same, what do? We look at the leading coefficient. In this case, the leading coefficients for both of these are 1s. So we would have a horizontal asymptote at the equation y equals 1. Okay. If I asked you for your domain, you would say that x cannot equal plus or minus 2. Yep, wherever those vertical asymptotes are. Okay. Now, we have some information about our graph. We have 3 points already plotted. We have 3 different asymptotes drawn in. I need more information than that to predict. One thing you can know is that if you have values in this section of your graph, you are not going to have values up here, right? Then it wouldn't pass that vertical line test to be a function. Okay, so we can pretty much figure out what pieces we're going to have. So we should expect that there's something down in this bottom section, down in here. We're going to have something in between these two vertical asymptotes, and we have something down in this section. Okay? If I had to make a guess without seeing a picture at all, without making a table of values or anything, I would predict something where I'm coming up along here and approaching those asymptotes. Yes? That seems logical. That's why those asymptotes are there. I would picture something up in here that looks like maybe a U-shape. It's going to approach those asymptotes. But I could just as easily have something that's doing this. All right? Kind of a twist. So I need more information than what I have. All right? I'm going to have you enter it in your calculator. Again, as long as you've given me the X and Y intercepts, any vertical asymptotes or holes, and any horizontal asymptotes, after that you can use your calculator. Okay? So grab your calculator. I'm going to clean this up a little bit here. All right, so on our calculator, now I have a second equation down in the y equals 4. Don't worry about that right now. The first one, y1, y sub 1. Notice that I put the whole numerator in parentheses, and I divided by the whole denominator. That's how you're going to have to enter it. Okay? Now there's two things that we're going to use. We're going to look at the graph of it, and we're going to look at the table. All right? I'm going to start with the graph. Does that look like what I was predicting? Okay. We need a few more points. I want to actually have you plot some. So we can go to the table, do second graph, and we can use some of these values to help us plot our points. Okay. Notice at 3, 0, right? We had found that one. That was one of our X-intercepts. Okay. And what happens at X being 2? What does it say for Y? Error. So we know that that's a vertical asymptote. We can't hit that value. Does that make sense? Okay. So go ahead and scroll up and down a little bit. Get a few more points. The idea is that we want to plot some points in each of those 3 chunks of our graph. Okay. So when X equals -8, we are at about 7/10. We know at -4 we hit 0. We know we're getting really close to the asymptote at X equals -2. So we would graph this. In between the 2 and the -2. At -1, I'm at 4. We already have our point at 0. And at 1, we're at 3.3, 3 1/3. Okay, so we have some dots. We can draw our little U-shaped curve. Remember, it is approaching those asymptotes. And then we need some values that are beyond X equals 2. We already have the point 3, 0. Let's go back over here and scroll down a little bit. What do you notice at 8? We hit 1. 1 was our horizontal asymptote, It is possible to cross a horizontal asymptote. It's never possible to cross a vertical one, but it is possible to cross a horizontal one. Look at what's happening after that. As we scroll, we're just above that 1 mark, right? But really close to it for quite a while. So what I would predict over here, we said at 8 we're right on the 1, and after that we are just barely above it. So we are coming up along here, we're crossing there, and we're going to level off just above that. Now, how could we have known that we were going to cross the horizontal asymptote if we didn't have a graphing calculator? Could we have plugged in a y value of 1 into our equation? Okay, so our equation was x squared, what was it, plus x minus 12 divided by x squared minus 4. And we said, what if that y value was 1? Okay, if I cross multiply, I have x squared minus 4 times 1. And I have x squared plus x minus 12 times 1. We can solve that. Our x squareds are going to drop out. We get x minus 12 equals negative 4. Adding the 12 over, we end up with x being an 8. All right, so we've shown that that 0.81 does work in that function. Okay, so you can check to see if you're crossing the asymptote that way if you don't have a calculator. Questions on this problem? Are we clear on the details that you have to include on your own before you grab your calculator? Okay. I'm going to pause the recording. I want you guys to fill in those details, the x and y intercepts, the vertical asymptotes, horizontal asymptotes, and then we'll look at our graph. All right, so step 1 is to factor. How did you factor the denominator? X minus 5, x minus 1. Okay, so do any of our factors drop out? All right, so this has no holes in it. All right, we'll look at some tomorrow that have some holes. All right, let's go ahead and list our vertical asymptotes. What makes that denominator 0? Okay, so we have an x equals 1 and an x equals 5. All right, no holes. If we had to list the domain, we can say that x cannot equal 1 or 5. Okay. X-intercepts, where do we look for those? In the numerator. So let's look at the numerator. When does the numerator equal 0? Okay, so negative 3, 0 will be one of my x-intercepts. Y-intercepts is what we get when we plug a 0 in for x. Okay, so put a 0 in for x. We end up with, if we put zeros in for all of these, okay, 3/5. And then horizontal asymptotes. That's based on degree. What's the degree of the numerator? Degree of the numerator. 1. Degree of the denominator. 2. Right? Degree of the numerator is 1. Degree of the denominator is 2. So what do we do when the top degree is smaller than the bottom degree? Y equals 0. Okay. All right, let's draw in our asymptotes. We have one at 0 here. Now notice our asymptotes at y equals 0, but we had an x-intercept, right? So we are going to cross through that asymptote again. But it is in there because as we move farther away from the origin, we should be leveling off near that asymptote. Okay, just not right close to the origin. All right, vertical asymptotes at 1 and at 5. All right, so we're looking at the one that I have stored here under Y4. Okay. You can go to the equal sign and turn them on and off. All right, so if you want to enter several equations, but you only want to look at one at a time, just have the equal sign unhighlighted, and you won't see that graph. Okay, so I've highlighted the Y4 equation here. X plus 3 divided by x squared minus 6x plus 5. Looking at our graph, does it fit what we already put on our graph? Yes? Okay. Let's look at the table so we can plot a few points. We know that our graph has an x and y intercept over here on the left, so we have to be coming down along here, crossing through there, and then leveling off. Does that fit with what we're seeing in our table? So let's look at our table to the left of 0. We're just barely under that x-axis for our y values. Okay. Then looking at what's happening in between the vertical asymptotes at 1 and 5. All right, so notice at 1 and 5 it says error because we have a vertical asymptote there. At 2, we're at negative 1 2/3. At 3, we're at negative 1 1/2. And at 4, we're at negative 2 1/3. Okay, so kind of an upside down U shape in that section. Okay. And then we want to see what's happening to the right of 5. So at 6, we're at 1.8. And at 7, we're at about 8/10. So probably looking at a branch coming down this way. Okay. Does that look like what our graph showed us? We'll go back to the graph here. Yes? Seems to be fitting okay? All right. Do we cross the x-axis, which is our asymptote in this case, right? The horizontal asymptote. Do we cross that anywhere besides here at negative 3? No, we didn't have any other x-intercepts, right? If we were going to cross that x or that y equals 0 line, we would have had to see more x-intercepts, and we don't have them in this case. All right, our last question. It says you work in a pharmacy that mixes different concentrations of saline solutions for its customers. The pharmacy has a supply of 2 concentrations, a 5/10 or 0.5% solution and a 2% solution. The function y equals 100 times 2/100 plus x times 5/1000 divided by 100 plus x gives the concentration of the saline solution after adding x milliliters of the 0.5% to 100 milliliters of the 2% solution. How many milliliters of that 0.5% must be added for the combined solution to have a concentration of 0.9%? Okay. For this question, you are being given the formula. Tomorrow we're going to start looking at setting these formulas up. So I want to talk about where this function's coming from. Okay. If you look at the denominator, it said we were starting out with 100 milliliters of a 2% solution. We are trying to dilute that down, right? We're trying to take this 2% solution, get it down to a 0.9% by adding a weaker solution to it. Okay, so total volume, we had 100 milliliters, and we're adding some unknown amount of this weaker solution. So the denominator is your total volume. Okay, the numerator is going to be how much of this acid stuff, or sorry, saline in this case, how much of this volume is actually saline. Okay, we have 2% of our 100 milliliters is saline. That's what a 2% solution means. It means 2% of your quantity is the actual saline solution. Okay, the rest is water. So we have 100 milliliters. Of that 100 milliliters, only 2% is actually saline. Then we are adding to it some number of milliliters that is only 0.5%. Sorry. So 0.5% would be 0.005, 5 thousandths. Does that make sense where the equation is coming from? Okay. It's asking us to figure out how much this X should be so that we get a concentration that's 0.9%. What would that be as a decimal? 0.9%. We have to move the decimal over 2 places, right? So we're going to have a decimal and 2 zeros before our 9. Okay, that's what we want our Y value to be. I want you to think of this as a proportion, right? And cross multiply. So you're going to have 9 thousandths times the 100 plus X from our denominator equaling, so that's that direction, equaling 1 times this whole numerator. All right, simplifying. What do we get when we take 9 thousandths times 100? Times it by 100 moves our decimal back 2 places. Okay. 9 thousandths times X is 9 thousandths X. 100 times 2 hundredths is 2. And we have 5 thousandths times an X. Can we get all our X's to one side? I'm going to subtract these over here. So we have 4 thousandths X left. And can we subtract the 9 tenths over here? 2 minus 9 tenths would be 1 and 1/10. All right, take that divided by 4 thousandths. What do we get for X? All right. So our X value is going to be 275, and that was milliliters. So we have 100 milliliters of 2%. We're going to add 275 milliliters of this weak 0.5% solution to dilute it down to a 0.9% solution. Does that make sense? Okay. All right, so you guys are going to do day 2. I will get you some graph paper for that, yes.